In this video, we're going to be looking at the sine rule and the cosine rule. Okay, when do we use them? Well, Pythagoras and SOHCAHTOA is only used on right angle triangles. If you remember, Pythagoras is used when you have two sides and you're trying to get a third side, and SOHCAHTOA can be used when you have two sides and you're trying to get an angle, or when you have a side and an angle and you're trying to get another side. However, they only work for right angle triangles, so we need something else when we don't have a right angle triangle. And that's where sine rule and cosine rule comes in. So let's start by showing you how to label your triangle. Now the angles are going to be labelled with capital letters. Sides will correspond to the angles opposite it. So you have opposite angle A, side little a, opposite angle B, side little b, and opposite angle C, side little c. Now the angles can be labelled in any order you like, capital A, capital B, and capital C. However, in the formula you've got capital A, so it makes sense to label the angle that you know as capital A, and you'll see why later. Let's now start with the cosine rule. Here we have two scenarios where you can use your cosine rule. In the first one, we have an angle with two adjacent sides next to it as known. And the side you're trying to work out is opposite the angle that you know. And if you have this scenario, you can use your cosine rule. And here's the formula you'll use, the cosine rule. A squared equals b squared plus c squared minus 2bc cos A. And that minus 2bc cos A means minus 2 times b times c times cos A. And you'll just simply go ahead and fill that in. And I'm going to show you how to fill that in shortly. I'm just going to quickly look at the second scenario when we can use our cosine rule. In this situation, we have all three sides known. And when you have all three sides known like this, you can work out any angle. It's not just the angle I label as capital X. You can work out any of the angles. The formula you'll use when you do have scenario 2 of the cosine is the same as the first one. However, it's easier to use a rearranged version, and memorizing it might save you a few moments in your exam. And here we have the formula. So if you fill in that formula, you can work out what cos A is. Of course, in this case, it will be cos X, as your A is the angle unknown X. So let's go back and finish off the working out for our situation 1. And we'll start off by labeling our triangle. Since in the formula we have capital A, we'll label the angle that we know as capital A. And the other two angles will not matter which way around you label them. X will be little a as its opposite capital A. 10 will be little b as its opposite capital B. And 8 will be little c as its opposite capital C. Let's go ahead and fill that in our formula. And the awesome thing you'll find is you can throw all of that into your calculator in one go, and it'll work out x squared without doing any bid maths error. And once you've got x squared, you can square root that to get your x value. So it's 5.04 to 3 significant figures. That's that done. So let's go and finish the working out for our situation 2. Since we're working out angle X, we might as well label that capital A. And as before, the other two angles will not matter which way around you do them. Let's go ahead and fill that in. And that gives us cos X equals 19 over 240. And remember, to work out angle X, you need to do shift cos. That's the inverse cos of 19 over 240. And that gives us 85.5 to 1 decimal place. And these are the only two scenarios where you can use your cosine rule. Let's now look at the sine rule. Again, the sine rule has two scenarios when you can use it. And here we have our two scenarios. In both cases, you'll be more or less using the same formula. But in one case, you'll be using the upside down version of the other one. When you're trying to work out the sides, you'll use the formula with the sides on top. When you're trying to work out the angles, you'll use the formula with the angles on top. Okay, so how do we spot the sine rule? So when can you use it? You always need a full section. And what do I mean by a full section? You need an angle and its corresponding side both known. And that's your one full section. And you always need that in your sine rule. So this triangle, if you look here, we have the angle 20 and its corresponding side, which is 10, both known. So we have our full section. Next, if you're trying to work out a side, you must have the corresponding angle to that side known. We can call that a half section. So you always need a full section with everything known and a half section. Now that we got that, we can start filling in the formula. Now we're going to start by filling in the full section. So that's 10 over sine 20. And that equals, now we're going to fill in a half section, which is going to be x over sine 80. Now we're going to need to do a bit of algebra to work out the unknown side x. And you're just going to times both sides by sine 80 to get rid of that sine 80 below the x. Throw that in your calculator now. And you get x equals 28.82 1 dp. Now let's look at our scenario 2. Now remember, in the sine rule, you always need that full section. Let's see if we got that. So here we've got the side 8 and its corresponding angle 35 known. So we have that full section. Now here we're trying to work out this angle x. Now remember, you need a half section. So if you're trying to work out angle x, you need the corresponding side known. Otherwise you won't even have a half section. And we do know the side opposite the angle x. So we have our half section. So sine rule can be used. Let's go ahead and fill in the formula. Let's start by filling the full section. So that's sine 35 over 8, and then fill in the half section. And that's sine x over 5. So we need to do some algebra again. And the main thing is we need to get rid of that 5 underneath the sine x. And you'll just do that by multiplying both sides by 5. And that will give us sine x once you put it in the calculator. Now, of course, you can't separate the sine and the x just by timesing or multiplying. You need to do the inverse of sine, the shift sign. So once we do the inverse of sine, we get x is 19.3 to 1 dp. And here we have it, the two scenarios for the sine rule. Now remember, if you don't have one of these two scenarios, you might just need to do a step before it, get one of these scenarios, and then go ahead and use your sine rule. Okay, so here we've got some triangles. And in each case, I'd like you to say if it's a sine rule, cosine rule, or neither. So take a moment, pause the video, and have a go. Okay, so let's look at A. Now we've got two angles involved, so I'm already thinking the sine rule. And remember, for the sine rule, we need that full section. Now, do we have that full section? So with the angle 50, we have the corresponding side known. So we have that full section. And we're trying to work out the angle x. Now, do we have its corresponding side known? Yes, we do. So we have a half section. And it's the scenario 2 of the sine rule. So we can go ahead, fill it in, do a little algebra, and work it out. Let's now look at B. So there's only one angle involved. So I'm thinking it might be the cosine rule. So here we've got an angle known and two adjacent sides next to the angle both known. So it's perfect for our scenario 1 of the cosine rule. Let's now look at C. So again, there's only one angle involved, so I'm thinking the cosine rule. So here we don't have the two adjacent sides next to the angle known. One of them is 10, however the other one is x, and it's unknown, so we don't have both adjacent sides known. So this does not fit our scenario 1 of the cosine rule, nor does it fit the scenario 2, because in that one we needed all three sides known. So we can't use the cosine rule as we have done before. However, we'll come back to it as you can do another step before it and then use the rule to work out the side x. Let's look at D now. Okay, two angles here. So we're thinking the sine rule. So we'll ask ourselves, do we have a full section? And yes, we do. So we're trying to work out this side x. Now, we don't have the angle corresponding to it known, so we don't have a half section. However, that angle we don't know can easily be worked out as we have two angles in this triangle. And you can use the fact that in a triangle, angles add up to 180 to work out the remaining angle. And then you've got your half section and you can go ahead and work it out. Okay, let's look at E now. So there's two angles here. So I'm thinking the sine rule. Do we have a full section? And yes, we do. So we're trying to work out a side here. So we must have the angle corresponding to that side known. And we've got that corresponding angle known. So we have that half section and it's perfect for our sine rule. And that will be our situation 1 of the sine rule. So let's now look at F. Now there's one angle involved, so I'm thinking it's the cosine. Now all three sides are known, so we can use the cosine rule, and it's our scenario 2 of the cosine rule. Now I said I'd go back to C, so let's look at C now. Now what we can do is we can answer a different question first, and that might lead us to what we're trying to work out. So what I could say is, let's work out this angle here. And that will allow us to use the sine rule, because you've got the full section with the 100 and the 30. And the angle I said will work out, I've got the side corresponding to that known, so I can work out that angle. And once you've worked out that angle, you can work out the third angle, using the fact that angles in a triangle add up to 180. And now you have your situation 1 of the cosine. You have an angle with two adjacent sides known, so you can go ahead and work it out. Of course, you can also use the sine rule again to work out what you need. And there we have it. I hope you found that video useful. Support us by liking, subscribing, and share this with your friends. And if you still got some more questions on anything, drop a post on our forum at examqa.com where you'll find your questions answered.